Hello everybody, it's the 11th of February today. Before I start the video proper, I just wanted to bring you up to date with where we are on the supply of boards to build our preamp. It's kind of good news, but kind of bad news as well. First of all, the good news, which we'd like to thank everybody that have participated in the purchase of these boards, and as you've probably been aware, they are all of them have been sold in America. Now, it's not because of any government ruling or anything like that. It's simply that we opened an account with eBay, and the amount of hoops you have to go to be able to supply to you good folks is just almost beyond belief. But saying that, we're almost there. I won't trouble you with all the details on this video, although we may make a video all about it because it's quite involved. But basically, all the boards we put on the market originally were about, I think from memory, was 125. All of those sold in a 24-hour period, and then we're out of stock. I know some people think there's some kind of fiddle going on and we don't want to supply people in far off places in the world, but it's untrue. We just could not supply them to anyone other than living in mainland. Even Canada, just across the road, we couldn't supply those. We are expecting another 100 odd boards to be available in about 2, maybe 3 weeks time. The delay in this case is because our friends in China are having their annual holidays. So absolutely nothing we can do. The order's been placed, and as soon as they return, well, they said they can't complete the order. So that's all we're waiting for. That's partially the good news. But the bad news is, again, these will only be available to America. Not our choice, it's eBay. We, as a new company, we have to jump through lots of hoops. Everybody has got to like the product. So those that have bought it already, please go to eBay and say it's brilliant and how wonderful it is. Because the more of you do that, the quicker you do that, the sooner we can supply the rest of the world. Keep an eye on the advertisement on eBay and or on the videos, because the moment I find they're available, I will let you know. So I'm not one to tell you to subscribe, because you know I don't care if you do or not. But in this case, if you do subscribe, you'll know instantly when more boards are available. This is a typical transformer for use with our preamp. This is the primary, and this is what you connect to your main side. Now, the voltage of this will depend on your country. Here in New Zealand, we have 230, 240 volts. Now, this particular transformer comes from, guess where? China. And majority of their transformers are 220 volts primary. Now, that's quite acceptable to use that with a 240 volt supply. But what that means, in fact, that the output will be that little bit higher. So instead of getting 15 volts, you could get 16 or maybe even 17 volts. This is uncritical for this application because the board itself has its own regulators built in, which are these here, and they will reduce the voltage to the required 15 volts. Here are the wires coming out of the transformer, and you can see there are 2 blue wires and 1 yellow wire. Now, this is not universal by any means. What it does mean is on this particular transformer is that is 115 volt, that is the naught or the reference level, and that is the other 15 volts. To show you what I mean, I'm going to bring the meter into circuit and switch the power on. Don't forget your meter should be AC at this stage. You'll see where I'm connected to now between the naught and one of the 15 volt supply. You can see we're actually getting 16.7 volts. Now, I did explain this earlier insofar as this is a 220 volt primary, and we are currently 236 volts AC going in. And also another reason why it's slightly higher is because the load on the transformer is very light, only about 20 or so, well, probably a bit more because we're including the regulators here. It's consuming less than 50 milliamps, so the voltage will be effectively off load. The other thing you can do to prove that you're correct is to go across the two secondary, and here obviously the 15 is doubled, and that would normally give you 30 volts, but as we're running a little high, we have in fact got 33.7. Absolutely no problem at all. So that's a very simple test you can do with your transformer, but I would suggest you do it prior to connecting it to the preamp, because if you do make a mistake here, you could end up with a minor but definite disaster. This particular transformer is a half amp, so 500 milliamps, so in real terms it's 5 times bigger than it need be. So you could find a transformer that is really small and it will be fine. Equally, you could find another transformer that's 3 times the size of this. Will it affect the sound? Absolutely 100% no. The current consumption on a preamp is more or less constant. It varies very slightly with signal, but not so as you'd notice, and it doesn't really matter because the regulators keep the voltage constant. If this was a power amplifier, the size of the transformer and the smoothing capacitors would be very important, because there you're drawing many amps of current, and it could be as low as 20 or 30 milliamps under standby conditions, or quiescent if you're posh, and then many amps on peak signals. So these capacitors, theoretically, the larger they are, the better it would be. And you will see these are huge on power amplifiers. These are more than high enough capacitance in this circuit. And don't forget, of course, there are also more here. A quick word now about choice of potentiometer and how to connect it onto our amplifier. This is the very well known Alps pot, and in this particular example it is supplied with a PCB which allows easy connections. This isn't connected yet, it's just pushed in to show you what you get. This PCB can be ordered from the same supplier of the Alps pot. We don't supply either of these because that's down to you to decide what type of pot you want. I would suggest you use a 50K, they're readily available, but again, if they're very cheap, i.e. about $3 or $4, you're almost guaranteed that it will be fake. A couple of my viewers have commented why I have a cheap and supposedly nasty pot on my prototype? Well, the answer is very simple. I would normally fit an Alps pot, but when I started to build this, I hadn't got any in stock, so this one wasn't available. You can see the difference in size and construction. There's a couple of things you need to know about pots. Now, the Alps pot has got a reputation for reliability and quality. My actual stock at the moment, I have got 3 Alps pots in stock, all from the same supplier, and I've got loads of these generic, if you like, unbranded pots. You might be surprised to know that only on the samples that I have, of course, this pot is actually more accurate in terms of balance between one channel and the other. But it's clearly of a lesser construction and literally cost about $3. Whichever pot you choose, it will make 0 difference to the sound. It really, if you believe anything different, I don't propose to argue. If you think that spending 4 or 5 times the amount is going to give you a better sound, then okay. But this is the one that I've done all my tests on, and the track matching between the two is within a dB from one to the other, which, although that may sound a lot, this particular Alps pot is nearly 2 dB out in part of the range. So in terms of, if you like, balance between the signal, this is a better pot. You'll notice on here there is a terminal. That is because these are made of metal, not surprisingly, and it's effectively what holds it together, and it also gives screening. As this is just laying on my test bench, when you touch the potentiometer here, or well, anywhere, it will make a buzz in the sound. I've taken the earth from here just to the earth terminal on the input board. But here's where you have to be careful. Don't be tempted to do that if this pot is actually mounted in a chassis, because your chassis should have an earth, and if you then mount this on the board or in the chassis, it will be earthed via that nut there. So don't double earth it, because if you earth it to the input and it's connected to a metal chassis that's earthed, you will have an earth loop. It will buzz, and it could cause oscillation and all sorts of things. The board itself has what you call star earthing. In other words, all the various circuits go back to one point, and that is very important in a preamp. Another word, if you like, about the potentiometer. So you've chosen one. This little diagram shows you how to connect it. If you're using very short cables within a chassis, it's debatable that it needs to be screened. But whatever you do, tuck the wires right down to the bottom so they're touching it could be a steel chassis or aluminium. I don't know what you've got. I'm sure you will know that the cable that is going from your DAC or chosen pieces of equipment will be screened. You will never find them unscreened. So the input will go straight from your DAC, maybe via a plug-in socket, but if not, the wires will go straight to the potentiometer. I mentioned in an earlier video the importance that the semiconductors are genuine, and my main concern is the 5532. There is a very quick way to tell if it's a fake or not. Now, I have made a video on this 4 years ago now, and people are still looking at it today, so I'll put a reference in the comments. Here is a very brief description as to why. Take the IC out, identify the pins. Pins 2 and 3 should have a diode reading in both directions. And that's because there are 2 diodes on those 2 pins, which is basically across the input. There are other pins you can measure for the other channel, but you don't need to do that, because if it's fake, it will have no diodes and there will be no reading on the meter. It's simply because fake 5532s aren't manufactured as fakes. They are another IC, and the 5532 seems to be the only one with these double diode protection on it, so you can be 99% sure. Another common question is input sensitivities and output voltage. This particular slide shows the input requirements for various outputs, and it's very comprehensive. Shows what I would consider to be a fairly normal output from a typical DAC. This is, of course, with the volume pot on full. Right at the end of the video there will be 4 more slides like this showing different sensitivities. They'll just be on the screen briefly at the end of the video, so you can pause and have a look if it's something that interests you. Something I forgot to mention in the earlier videos when I was describing the preamp is that, along with 99% of audio products, i.e. power amplifiers or preamps or any of these things, when you turn them on or off, there will be a disturbance of some kind. In power amplifiers, the disturbance can be so great that it will actually destroy your loudspeakers. A preamp, however, is usually much more gentle, but it's annoying and it is avoidable. Normally in a preamp it's not an issue, but there'll always be a plop or some sort of noise or disturbance when you turn the thing on or off. It's unavoidable. It's purely because the DC conditions take a second or so to settle down. As I said, normally this isn't a problem because the preamp feeds generally a power amplifier, which should have, for your own protection, a delayed turn on. Turn off on most power amplifiers is instant, so there's no issue. I'm going to show you this slide, not because I want you to be impressed or otherwise, but it's just showing you the difference. The blue is the 5532 and the yellow is the LME. Now, bearing in mind this is 100 kilohertz, and normally you wouldn't even show a square wave for that frequencies because it's largely irrelevant. If the square waves are good in the audio passband, that's what you should really judge. But this is really just to show you the difference in performance of those two ICs. It's actually not as bad as that in real terms. Both of those ICs do perform better. To maintain stability in the circuit, you have to add those small capacitors, 10, 12 picofarad across the feedback loops, and you do that purely to maintain stability, because I'm sure you'd rather realize that the circuit is stable or that it produces a better square wave at 100 kilohertz. It's almost, who cares? Stability is the most important thing. This performance is really, I can only think of this as a possible reason why subjectively the LME does have that edge over the 5532. Clearly, it's not anything that's happening in the audio passband, because you've seen the square waves and everything else is the same. I haven't bothered to show you a square wave at low 2 or 3 hertz because they're both absolutely identical. And as the circuit's DC coupled, you'd expect that to be the case via the one capacitor in the output, which really makes no difference. Try it. Once you've built it, short that capacitor out. It's there for safety. If you're happy that you've got no way of passing on any problems, DC offset or other, or your amplifier already has a capacitor, you can omit that capacitor. These last 2 slides are just to show you stability, basically. This is square wave with a capacitor on the output and without one. And well, good luck to you if you can see the difference. But all the slide is meant to show you is hanging a relatively large value capacitor on the output of the preamp. It doesn't really care. You know, I mean, the value that we've used on this test is way above what you would be using on many meters of cable. So that's all it's meant to show you, that it doesn't oscillate, it doesn't ring, or I mean ringing would be the, well, it could do either really, or both if it's a really crap design. That's the end of this video. I hope you found it interesting. If you've already built the board, could I ask you to possibly upload some pictures onto eBay for people to see? We'll look at them, and if you've got any comments to make, good, bad, tell us exactly what you think. And if enough people like what we've done, who knows, there might be something else on the horizon.